everyone. Welcome to Cloudy ML. Today in this particular video, we are going to discuss a very important project which is based on clusters. That is called, the project name is customer analysis. So, based on the spending habits of the customer, we will segregate the customer into two or three or four, any number of clusters that is formed based on the algorithm. So we'll segregate the customers and we will target those customers who like to spend more on things which are newly sold in the market. So the companies or firms can target these type of customers so that their products are sold. So let's discuss about the project, what it is, about the data set, the problem statement. Customer personality analysis is a detailed analysis of a company's ideal customers. So, as I told you, that the company will, if the company launches any new product, it needs to target a particular set of customers. So, here the company will target those customers. It helps a business to better understand its customers and make it easier for them to modify products according to the specific needs, behaviors, and concerns of different types of customers. Customer personality analysis helps a business to modify its products based on its target customers from different type of customer segments. For example, instead of spending money to market a new product to every customer in the company's database, a company can analyze which customer segment is the most likely to buy the product and then the market the product only on that particular segment. So as I told you, based on data, whatever data the company collects, it can identify the best target customers for its newly launched product and target only those set of customers. So what is the column information we are having? We are having the ID, that is the customer unique identifier, year of birth, the customer's birth year, education, that whatever education the customer is having, marital status, income, kid home, that is number of children in the customer household, teen home, number of teenagers in the customer's household, DT customer, it is the date of customer's enrollment with the company, like when he first purchased a particular product or any product from the company, that date is this. Recency is the number of days since customer last purchase. Complaint is 1 or 0 if the customer complained in the last 2 years or not. Products is M&T wines, amount spent on wine in last 2 years. M&T fruits is the amount spent on fruits in last 2 years. M&T meat products, amount spent on meat in last 2 years. M&T fish products, amount spent on fish in last 2 years. M sweet products, amount spent on sweet products in the last 2 years. M&T gold products, that is amount spent in gold in the last 2 years. Promotion. Now this is what num deals purchase, number of purchases made with a discount. Accepted CMP1. So these are different columns we have in the data. Accepted CMP1, that is 1 or 0 if a particular customer accepted the offer in the first campaign. Whenever the company launches its new products, campaigns are conducted, and whether the customer accepted the offer in the first campaign or not, it is based on that 0 or 1. Similarly, we have accepted campaign 2, accepted CMP3, accepted CMP4, accepted CMP5, and the response. Place, that is the num web purchase. Now this column shows that number of purchases that were made from the company's website. Similarly, num catalog purchases made from the catalog of the company. Num store purchases, that is purchases made from the store of the company. Num web visits month, number of visits to a customer website in the last month. And the target column is need to perform clustering to summarize customer segments. So this is the target column. We will need to perform some kind of operations on the data and form clusters based on the analysis we perform. So let's start with the project. In the starting, we'll import the libraries, that is the datetime library and the pandas library, numpy library, cborn, matplotlib. Okay, so let's run this. I've run this two cells. Now this input warnings, whenever warnings we get in the whatever code we write, we'll not get those warnings. That's why we are writing this. Now this particular piece of code I have written, if you are running it in Google Colab, you have to run these two sets of code to get the data. Okay, in Jupyter Notebook you can simply import the CSV file. Okay, now let's read the data set. This is the data set we have. The columns I already explained you what are the columns we have. Now, whenever you are doing any machine learning projects, there are some standard processes that we need to do, like check the columns, check the shape of the data set, check the missing values. These are all common steps that you need to perform in all the projects. Okay, I'll not just only tell you that how we'll be solving this project, but also how we will be approaching this project and doing it. That also, let's try to understand. So we'll check the columns, df dot columns. These are the columns, and I already explained you what these columns are. Okay. Now let's check the shape of the data set. The shape of the data set is 2240 rows we have and 29 columns we have. So obviously one idea you can get that we will not be passing all these columns to the model. Okay. We will try to do some feature engineering and bring down the columns. Okay. Like we'll make the columns less. Let's check the information df.info. So these are the particular information you get. What is the D type, how many null values are there and all. Okay. Let's check the basic statistics of the column, of all the columns. So this is the basic statistics of the column. From here, some important columns are like income. You can see that the income value, the mean income is 52,247, and the minimum income a person is getting is 1,730 rupees, and the maximum is 6,66,666 rupees. So let's check for the null values. We have any null values or not. So we have a particular called income in which we have 24 null values, and rest all are all right. We have no null values. So next what we will do is, since there are some missing values in the income, we will check the column and replace the values with mean or median. So let's check how the distribution of income is. So we can see that the data is left skewed. So now whenever the data is left skewed, that is not evenly distributed, we will not replace the mean values with the we'll not replace the missing values with mean. We'll do it with median. Like for income column, you can understand the graph. Suppose the world population is there. So we'll, if you analyze each and every person's income, only some people will be falling in one category who are having high income. Most of the population will be having low income or mean income. Okay. So we'll replace the missing values with the median. Okay. Let's check for any duplicate values. We don't have any duplicate values also. Okay, now we are checking how many unique values are there. ID, so we had 2040 rows, so each customer will have its own unique ID. Year of birth, education 5, so these are the all the unique values we have. Okay, in the above cell we can see that the Z cost and the Z revenue have same value in all rows. That's why we are not they are not going to contribute anything in the model, so we can drop them. Okay, if you want to see also what these columns are, so Z cost contact, this is the Z cost contact, and one more column was revenue. So let's see that column also, Z underscore revenue. Okay, these two columns are not making any sense. Okay, they are in the same values. Okay, like you can see only one unique value is present in Z cost 1, and in Z revenue also we have only one unique value, that is 11. So we'll remove these two columns. Okay, these two columns are removed. Now let's check the column names, whatever we are having. So these are the columns with Z cost revenue, cost contact and Z revenue removed. Now we are having this many columns. Let's perform a univariate analysis. What is a univariate analysis? In this we will perform like each and every column we'll analyze and try to find out what we can do with that particular column. So number one is analysis on year birth variable. What is year birth? Year birth is the customer date of birth. So these are the unique values we have in year births. 1976 we have most number of customers, then 71 and so on. So we have defined a function which will plot a bar plot, or you can say the count plot for the particular column. Now this is of univariate year birth. So you can see the data. This data is uniformly distributed. Like we don't have any, like left skewed or right skewed part. So the data points in year birth are uniformly distributed. Next column is on education column. Okay, let's check the unique values in education column. We have graduation, PhD, master, basics, 2n cycle, whatever we have. So what we will do is, for this column, whatever we have as education will replace all these values except the basic one will replace graduation, PhD, masters, 2n cycle with post graduation, and will replace basic with undergraduate. Okay, so this is the code for replacing it. Df education dot replace, like these all values we are replacing it with postgraduate, and basic we are replacing it with undergraduate. So let's check that. We have for postgraduate we have around 2000 records, and less number of records we have for undergraduate. Okay, let's perform the analysis on marital status variable. Now for this also we have many unique values like single, together, married, divorced, widow, alone, absurd, YOLO. Okay. Now people who are living single, like we have single, we have divorced who is living single, we have widow, alone, YOLO, absurd. For all these values we'll replace it with single, and we have married and together we'll replace it with relationship, so that we get only two unique variable. So you will get an idea that why we are performing this type of operations to make the unique values less, so that we can make this a categorical column, and we can replace like 0 or 1 with this. For single we can put 0, and we can put 1 for relationship. As we know that the machine learning model doesn't understand string variables, or you can say object data type. It understands only integer, or you can say boolean 0 or 1, this type binary type of data formats. So for single, we have less number of records, and for relationship, we have more number of records. 64.46% of customers are in relationship, and 35.53 customers are single. So now let's like perform an analysis on income column. For income, we have already discussed that the mean income was 52,237, and the median income was 51,381. So let's perform the distribution plot. So we saw earlier also that the data was left skewed. Okay, this is the box plot for it. So you can see we have one outlier also. Okay, we'll treat this outlier later. Okay, the income column is left skewed, and we have some outliers that we will treat it in the later stage while model building. Okay, next what we are having is teen home. Let's understand what the teen home column shows. It has only three unique variables, that is 0, 1 and 2. For kid home also we have 0, 1 or 2. So what we will do is we'll replace these two columns with kids, and we'll add the result of these two. Suppose a particular home have two kids and one teenage, so we'll replace those two particular columns with kids, and we'll add these values. Okay, so these are the number of kids. 50.35% of customers in the dataset have one kid. 28.48 customers in the dataset have no kids, and 18.79 customers in the dataset have two kids, and 2.36 of the customers have three kids. Okay. Now let's perform the analysis on MNT wines, MNT meat products, MNT fish products, MNT sweet products, and so on. So this was the amount spent on meat products and all. So we saw the description of the column. What does this column show us? So these columns were showing us amount spent in wine and amount spent on foods. Okay, in the last 2 years. Let's go to that plot again. Okay, we are checking the unique value. So the amount spent, okay, we'll treat that as expenses, and we'll add all the column, like we'll add the amount spent on wines, amount spent on fruits, meat products, fish products, sweet products, and gold products, and we'll make that column as expenses. Okay, this is the plot for expenses. Okay, in this also you can see that the mean value of the expense is 605 rupees, and the median value is 396 rupees. So here also the data is left skewed. Okay, this is the box plot for the expenses. The distribution is uniform. Next, we have accepted CMP1. So this was the column showing us that the customer has accepted the offer in the first campaign, second campaign, third campaign, fourth campaign, and fifth campaign or not. So what we will do is we'll also add these columns. All the columns we will add and we'll make it as total accepted campaign. Okay. So here in the plot, we are plotting the you can say the count plot of this total accepted campaign column. Okay, for 0, so this particular set of customers didn't accept any campaign. Okay, for 1 we are seeing that this particular set of customers accepted only one campaign. This set of customers accepted two campaigns. This particular set of customers accepted three campaign, and this particular set of customers accepted four campaigns. So this is the like result of the plot shown here. As I told you that most number of customers didn't accept any campaign. Okay, next we have this web purchases, catalog purchases, number of store purchases. So we'll add all these columns and we'll make that in one column, that is num total purchase. Okay, so this is the num total purchases column. Let's check the description as it is a numerical column and plot the count plot for it. So you can see that the customers like total purchases, the mean value is 14 and the median value is 15. Okay, what was this total purchases column? So let's check that column also. um, so the number of purchases made through the website and all, this is showing that. Sorry, let's come to that part. Okay, total num purchases, this is the distribution plot for that. Okay, now we have performed some feature engineering and removed so many columns. Let's check that columns. We have reduced it to 31 columns. Okay, you should check the column names also. These are the columns. Okay, now we have made some columns here from the previous column, so drop these columns later. Okay, now customer age. Now what does this customer age show? From the year birth we can get the customer age, that is today's year, that is 2023. We'll subtract the birth year, we'll get the customer's age. Okay, this is the customer 66, 69, 58 and so on. Let's check the distribution plot for the customer age. So it is like most of the customers are in the middle age, that is from 35 to 55, you can say. Okay, so columns to delete, we'll drop all those customers from where we have already taken out the information and made a new column. We'll drop these columns. Now as you can see, we have reduced the columns to how many columns? df dot columns. Okay, we have only, you can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 columns. Okay, let's check the information of the columns. For education, we don't have any null values, nothing is there, so the data is clean now. Okay, in the next step I'm going to create a feature out of the DT customer. What was the DT customer? DT customer was the date on which the customer has enrolled with us. Okay, that indicates the number of days a customer is registered in the firm database. Okay, however, in order to keep it simple, I'm taking this value relative to the most recent customer in the record. So what I'm doing is, in this, like first step, I'm converting it into the date time format, and then I'm finding out the latest record and the oldest record. So the newest customer enrollment date was this 2024 December 6, and the oldest customer enrollment date was 2012 January 8. So creating a feature customer 4, in this what we will do is we'll find out the number of days from which the customer has enrolled with us from the last record date. Okay, of the number of days the customer started to shop in the store relative to the last record date. So based on the last record date, what is the last record date? So the last record date is this one, the maximum one, this record date. Okay, so what we are doing is now we are creating an empty list. Okay, from D1. Now what is our D1 list? Our D1 list is this one. Let's run this piece of code first. Okay, now we are running this. let's check the dates. What is the dates column? Dates list. Okay, this is having all the information in the date time format. This is a list. Next, let's run this and run this. So now what information we got here? We got customer 4. So these are the number of days from which the customer has enrolled with us based on the last record date, taking it to be the newest customer from the maximum record date. Okay, if you didn't understand this, wait, I'll explain again. Suppose, okay, the latest record is 2014 December 6. Okay. Now what we are doing is, suppose a particular record we are having as this record. Okay. Now what we are doing is, from this particular date, that is 2013 8, this is the 8th month and the 21st day, we are subtracting this date, the newest customer date, from the this date, and finding out the number of days from the latest record. From the latest record, you can say, not from the last record date, from the latest record date, you can say. Okay, here d1 is what? The maximum from the dates list. This is the dates list and the maximum record will be this date. Okay, now what we are doing is, we are subtracting the d1, that is the maximum date, from each and every date, and we are appending it in the list called delta. Okay, now customer 4 is days and the customer 4 is the latest date minus that. As I told you, that we'll be subtracting it. Okay, now in the next step, what we are doing is, df customer 4 is equal to customer 4 dot apply lambda x dot days. So now what this days will be, it will be in the date time format, or you can say that this will be in the date format. From there we have to extract the days. Okay, we are writing x dot days now, so the number of days. Next, check the description of the date. The mean is 512 days. The median is 513 days. The maximum days the customer has enrolled with us is this one, 1063, and the minimum is 0. Why 0? Because this particular record, the newest date is this one. When we subtract the newest date with this record only, we'll get as 0. So for this record, it's showing 0. Okay. Now we'll drop all these columns, as these columns are no more necessary. We have extracted the information, and these 3 particular column we are not taking in use. So we'll drop these columns also. So this is the final data frame we have after cleaning it. Education, postgraduate and graduate we have, marital status, single relationship we have. This is the income column. This is numerical column. Kids column. This is also numerical column. 0, 1, 2, 3 and 4 will have continuous variable here. Expenses is also continuous. Total accepted CMP 0, 1, 2, 3, 4. How many number of campaigns the particular customer has accepted. Total number purchases. So this is the particular, you can say that the purchases, total number of purchases that were made, customer age, and the customer for how many days. So let's plot the test plot for this. So you can see that the most customers are regular to the campaign for 200 to 850 days, as most of the records are falling here. Okay, now let's perform the bivariate analysis. In this, we will take 2 columns for our analysis. Single column analysis was univariate. We have already done that. Now let's do bivariate analysis on education versus expenses. Okay, so this is the plot, that plt.figure sns.bar plot. In x-axis we are having education, and in y-axis we are having expenses. So you can see that the expenses of postgraduate people are relatively more than the undergraduate people. Okay, similarly for marital status versus expenses, so you can see that almost they have the same spendings, but some place you can analyze that here, that the single people are spending more than the relationship people. Kids wear expenses, you can say the people who are having 0 kids are spending more compared to the person who are having 1 kid, 2 kid and 3 kid. Here we observe something different, that the parents with 1 kid are spending more than the parents with 2 or 3 kids. Why? Because you can, put something in observation like this, that the person who is having one kid is likely to spend less than the person who having two or three kids. Okay. So, but we see an amazing observation here that person who are having one kid or zero kid are spending more than the people who are having two or three kid. Maybe they are saving or something like that in day. Okay. Total accepted CMP versus expenses. This is the plot for that. Okay, you can see here that the person who has accepted zero campaigns have less expenses than person who accepted one, two, three, or four campaigns. Total lump purchase. This is the plot. So total lump purchases versus expenses. So this is the plot for that. You can see it's increasing. Like the lump purchases are increasing. Purchases increase. The expenses also increase. Days engaged versus expenses. So here we don't see any relationship sort of thing, like whether the particular customer is for 200 days or 800 days, it's having the almost same kind of expenses. So let's check the scatter plot also for that. Like you can see, as I told you, there is no relationship between them, whether the customer is for 200 days or 1000 days, almost equal kind of expenses relationship it has. Let's check for customer age versus expenses. So for customer age versus expenses, let the chart plot. Okay. You can see that the customers who are having in the middle age range, who are from the age of, you can say, 40 to, you can say, 70, these kind of people spend particularly less than the people in this range. So teenagers, or you can say the person falling in the age of 25 to, you can say, 35, likes to spend more, and this side from 75 to 83, you can say. Here we can see some record in which the person's age is, you can say, 123, 124 also. Will remove this kind of records. So removing some outliers here. Shape. So we are removing the outliers. Customer age, we are taking only those records in which the particular customer age is less than 90. And for income, the maximum income, you can say, is 6,66,000. As I told you, one record was there in which we are having this kind of value, and 75% of the records are less than 68,289. So we'll take less than 3 lakhs. Okay. Any customer who is having income less than 3 lakhs will come in our range. Okay, let's check the shape now. Okay, yes. Originally, it was 2,240 rows. After removing some outliers, it is 2,236 rows. So we have removed 4 records. Now let's plot the correlation matrix. So this is the plot for code for the correlation matrix. We can see that the income, this is the income versus income one only. Income versus kids, you can see minus 0.34. Income versus expenses, it is positively correlated. Okay, this is also 0. Num purchases increases, the income will also income increases, the purchases increases. Okay, so the correlation result is income is positively correlated to expenses. Okay, and number of purchases, as we can see from here. Expenses is positively correlated to income, and number of purchases is negatively correlated with kids. So number of purchases is here and kids is here, so it is minus 0.25. It is having negative correlation. So the number of purchases increases, the number of kids decreases, as we have seen earlier also, that less kids were expensing more than more number of kids. Like if a particular family is having more number of kids, in that the expenses were less. Now let's come to the final model building part. But before that, let's see the data set. Okay. Here we will, for the label encoding column are these columns, education and marital status. We'll replace these columns with 0 and 1. So after replacing, this one looks like this. We have replaced postgraduate with 0 and graduate with 1, and marital status we have replaced single with 1 and relationship with 0. Now for rest of the columns, that is income, kids, expenses, total accepted CMP, number of purchases, customer age, and customer for will perform the scaling method, will perform standard scaler. So we are defining the method for standard scaler and we are doing fit and transform on these particular columns. So after that, the data set looks good. Now we have performed the pre-processing on these columns. We have performed the label encoding technique, and for these particular columns, we have performed the standard scaler. Now let's apply this particular records to our model and perform the clustering. So for clustering, we are taking k-means. Okay. Now we are taking a copy of the data set and we are storing it in X0 so that our original data set is not disturbed. Okay. We are importing the k-means library, and to check how many clusters are best based on error, this error has to be less. Okay, so we are using the elbow method. So we are defining, this is a standard procedure how we will check the number of clusters. We are taking WCS as empty list for k is equals to 1 to 11. We are checking for the range 1 to 10, sorry. Okay, we are fitting it and we are appending the inertia, that is the result, to the k-means. We are pending it in WCSS list. Okay, and we are plotting the plot for that. Let's run this. So for the best k, you can see the elbow is lying here. You can take k is equals to 4 also. Here the number of clusters will increase. You can take that also, but the best result is the elbow. Using the elbow method, we get k is equals to 2. Okay, so we are taking clusters as 2 and performing the predict method. So k-means is k-means, number of clusters is 2, random stick 42, and we are fitting it and we are predicting the result. Okay, so this will return, like it will return 0 or 1. So we are adding 1, so we'll get 1 and 2. Okay, you can simply add the pred also, but if you add directly pred, you will get, here is k-means cluster, you get 0 and 1. Instead of 1 and 2, you get 0 and 1. So the unique value will be 2 only, don't worry about that. So let's check that. So the distribution of clusters we are checking here. Okay, 2 clusters we have got. Let's perform the scatter plot on expenses and income based on the unique values from these clusters. So here you can see that cluster number 1, okay, this is one cluster of people and this is one cluster of people based on expenses and income. So you can see that the person who likes to spend more, whose expenses are more, are falling in this cluster, and the people who are having less expenses are falling in this cluster. Okay, so based on this, we have created 2 cluster and segregated the customers. Now this is one technique. You can also use another technique, that is PCA with agglomerative clustering. So k-means was one method of performing clustering. We are using one more method to perform clustering, that is called agglomerative clustering. And in this we'll use PCA also. What is PCA? Like we have initially supplied how many columns? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 columns. Here we'll cut down the number of columns. So we are creating a copy in X1. This is the original data frame. DF is the original data frame. Okay, we have not disturbed the original data frame. This is the original data frame. For PCA, we'll import it from sklearn.decomposition, import PCA, and we are reducing the number of features to 3. Okay, initiating PSA to reduce the dimensions to 3. We are fitting it on X1, and then what we are doing is, as we are creating 3 features from these features, we are putting that column names as column 1, column 2, and column 3. So PCA dot transform X1. So what is this X1? X1 is this one. So this is the distribution for that, column 1, column 2, and column 3. And further, we are plotting the 3D plot for that. Okay, X, Y, and Z. So this is the distribution. Like this less red one is column, like feature 1. The more red one is feature 2, and one more is feature 3. So this is a distribution in 3D. Now what we'll do is we'll perform the agglomerative clustering. This also has the almost same method, but before that we'll check what is the best k value for that. Here also we see that the best K value is 2 only, as the elbow is coming here. But you notice a very interesting thing here. When we performed PCA and supplied that to the K means, we got the number of clusters 2 only, but the WCSS, that is the error part, is a bit less. So you can see here for clustering 2, the error is around 6100. Okay. In the previous case, when we didn't perform PCA, the error was around 11,000 here. Okay, the error is around 11,000 here, but in this case the error is around 6,100. So after performing PCA, we have reduced the error, so we'll get more accurate clusters. Okay, so we'll do in agglomerative clustering, we'll perform clustering based on two clusters, we'll create two clusters. And similarly, AC is this agglomerative clustering dot predict the data frame will supply here, and we'll add it here. So what is this? We'll check here, x1 dot head. So you can see here also we got two clusters only. Okay, so let's check the plot again for the distribution expenses income in clustering performed using agglomerative clustering. So here also you can see this result only, that the people who are having less expenses are falling in one cluster, and the people who are having high expenses are falling in this cluster. Okay, similar result here also, but here the result is more accurate. Like these overlapping points are more accurate here based on what we performed earlier. Okay. Next, what we are doing is we'll draw some outcomes here. Okay, SNS dot scatter plot its income based on the cluster. He uses this cluster algo. So you can see that the people who are having more number of cluster like kids. Okay, the records which are in which the number of kids are more. Okay, in those people are falling in cluster 2, and the people who are having less number of kids are falling in cluster 1. So what is this cluster 1? Cluster 1 are those people who are spending less. So earlier in the observation also we saw that the people who are having more number of kids are spending less than the people who are having more number of kids. So we got the result here only, same result. And next what we are doing is we are checking based on marital status. So the people who are married, like one was for single, no, let's check that what was 1 and 0. Marital status, one was single and 0 was for relationship. So both the people are having same kind of relationship, almost same kind of relationship, like, okay, so this doesn't give any outcome here. Next what we can see is not this marital status versus expenses income. Okay, next, what we are having is income versus customer age. So you can see here the people who are having less income are falling in this cluster, and the people who are having more income are falling in this cluster. So this is which cluster? This is cluster number 2, and this is cluster number 1. Cluster number 1 was those who likes to spend less, and cluster 2 was those people who likes to expend more. Okay, this is the distribution of the cluster, and this is the final result. Like you can see how properly the two clusters are segregated here. Like this is one, this is one. X, Y, and Z. You can ignore this. Okay. So what is the final conclusion we draw? Cluster 1, people with less expenses. As we can see here, cluster 1 is for less expenses people. Okay, and cluster 2 is more expenses people. Next, people who are married and parents of more than 3 kids. So cluster 1 are those people who are married and are parent of more than 3 kids. So here you can see kids relationship. The person who are married, like married will have kids obviously. So these people are here, okay, and less number of kids are falling in this cluster. Okay, so this is that conclusion only. People with low income. Cluster number 2, people with more expenses, people who are single and are parents of less than 3 kids, people with high income. As this is having high income and more expenses, so these people will spend more. Okay, age is not a criteria, but it is observed that to some extent that people who are older fall in this group. You can draw a plot also, age versus customer age versus income. Okay, so you can see that the people here, the cluster is more dense. You can see here the cluster is more dense. Here the cluster is less dense. So you can analyze from this plot that the older people who are falling in this cluster likes to spend more. Okay, so this is that on. So the final outcome will be, okay, the customer falling in cluster 2 likes to spend more. So the firms can target people falling in cluster 2 for the sale of their products. Whatever product they are launching, the best set of customers they can target is cluster 2 customers. And now what are those cluster 2 customers? The people who are single, people who are parents of less than 3 kids. So the firms can target those households or those particular set of customers in which family is like, parents are single, or you can see that the parents who are having less than 3 kids. The firms can target those set of customers, those set of people, the sale of their products, as there is a high chance that these people will buy the products as their expenses are also high and the income is also good. Okay, so this is the final observation we draw from the project. I hope you like the project, and if you have any doubt related to this project, you can obviously ask in the comment section, and do comment how you like the project and whether you need any further projects on any topic based on your understanding. And whatever you understand, you can ask anything in the comment section. Okay, thank you. We'll provide this Jupyter notebook in the description, so check for that.